Gravitational waves are ripples in the fabric of space and time caused by acceleration of massive objects such as the collision of two black holes or the explosion of a massive star. Who first predicted the existence of gravitational waves and when? The gravitational waves were first predicted by Albert Einstein in 1916 as a consequence of his theory of general relativity. Now, how do gravitational waves differ from electromagnetic waves like light or radio waves? Now, these gravitational waves are entirely different from that of electromagnetic waves. They are a distortion of space-time itself, whereas electromagnetic waves consist of oscillating electric and magnetic fields. How are gravitational waves detected and measured? Now, these gravitational waves are detected using some specialized instruments called interferometers, such as LIGO, Laser Interferometer Gravitational Wave Observatory. And these instruments measure tiny changes in the length of their arms caused by passing gravitational waves. Now, what is the significance of LIGO and Virgo collaborations in gravitational wave detection, as I was talking about? Now, LIGO, these collaborations of scientists and institutions that have successfully detected these gravitational waves, opening a new era of astronomy by allowing the observation of the universe through gravitational wave signals. Now, what events can produce detectable gravitational waves? This is a very important question. Now, events such as collision of two black holes, the merging of a neutron star, and supernova explosions, these are some of the examples of astrophysical events that can produce detectable gravitational waves. Now, what information can we gain from detection of gravitational waves? Right? Very important question. The gravitational wave detections, they produce information about the properties of massive objects, their motions, and the conditions in extreme environments, not observable through electromagnetic waves. Now, what is the amplitude and frequency of this gravitational wave? Now, to answer this question, the amplitude of gravitational wave represents the size of the ripple in the space-time, while the frequency corresponds to the number of oscillations per second. Now, these gravitational waves from different sources have varying amplitudes and frequencies. Now, what is the significance of first direct detection of gravitational waves by LIGO in 2015? The first discrete detection of gravitational waves in 2015 confirmed a key prediction of Einstein's theory of general relativity and marked the beginning of gravitational wave astronomy. Now, what was the source of the first detected gravitational waves in 2015? Right? The first detected gravitational waves were generated by the collision of two black holes, resulting in a black hole merge. So the waves were produced from that collision. Now, how do scientists distinguish between gravitational wave signals and noise? Okay. Now, scientists use some complex data analysis techniques and algorithms to identify gravitational wave signals among background noise in interferometer measurements. They happen to have multiple detectors. They help confirm the validity of detections. Now, what are the implications of detecting gravitational waves from neutron star mergers? Now, gravitational waves from neutron star mergers, they provide valuable information about the behavior of extremely dense matter, the formation of heavy elements, and the expansion rate of the universe. Now, can gravitational waves be used to study the early universe? Now, these gravitational waves can certainly potentially reveal information about the early universe by detecting signals from cosmic events that occurred shortly after the Big Bang, such as inflationary processes. Now, the next important question is, how fast do gravitational waves travel? Now, gravitational waves travel at the speed of light, which is approximately 3 × 10⁸ meter per second in vacuum. Now, what is the importance of building additional gravitational wave detectors in different locations? Now, building detectors in different locations, such as the proposed LIGO India, helps triangulate the source of gravitational waves, improving accuracy and enabling a more precise understanding of astrophysical events. Now, how are gravitational waves related to the concept of space-time curvature in general relativity? Now, to answer this question, in general relativity, massive objects like stars and black holes, they curve the fabric of space-time around them. Now, gravitational waves are the ripples in this curved space-time caused by the acceleration of these massive objects. Now, what are continuous gravitational waves and how do they differ from transient gravitational waves? Now, the continuous gravitational waves are continuous signals generated by rotating asymmetric neutron stars or other sources, while transient gravitational waves are produced by short-lived violent events like black hole mergers or supernova. Now, how do gravitational wave detectors work at fundamental level? Right? It's a very important question. To answer this question, the gravitational wave detectors work by splitting laser beams, sending them down perpendicular arms, and these gravitational waves change the lengths of these arms, causing the beams to interfere differently, leading to a measurable signal. Now, what are the future prospects for the gravitational wave astronomy? I mean, to answer this question, the future of gravitational wave astronomy includes more sensitive detectors, more frequent detection, and the potential for uncovering new insights into the universe, such as understanding the dark matter and dark energy. The next important question is that how do gravitational waves contribute to our overall understanding of the universe? Now, these gravitational waves provide a new way to observe and study the universe, offering insight into the most extreme astrophysical events and confirming the predictions of Einstein's theory of general relativity. They enable us to explore the universe in a complementary way to traditional electromagnetic observations. And these were some of the basic questions and answers that are related with the topic gravitational waves. And these gravitational waves are produced either by a spinning neutron star or by a